Good afternoon, everybody. Welcome to our presentation on HVAC and facilities management and essential insights into energy efficiency. So just a word of who we are and who the presenters are. So there's Megan Chatterton, Sustainability Officer from the City of Sydney. Ethan Burns from Sustainability Now, he's an environmental engineer, and myself, Vasilios Giotis. I'm a mechanical engineer from Blue Green Engineering. So here are the topics that we're going to present. But let's talk about firstly the purpose of this presentation. It's basically to, in simple language and without jargon, to take away tools and knowledge that will help us make a better change to our buildings and to the environment. And to do this, we have structured this presentation into the following way. So the agenda consists of the latest building management technologies, going green with $0 and 5 things to do, analytical tools to forecast your building's carbon footprint, common pitfalls in contract management, rebates and trends and forecasts, NABERS, and Q&A. There'll be a Q&A session. So we envisage that the presentation stage will be about 1 hour and 15-20 minutes. So topic number 1, the latest building management technologies. Before we dive into this, first it'd be good to have a look at where the biggest energy users are in buildings. And over the years, after doing energy audits in high-rise and multi-story residential apartment buildings, we found that heating, ventilation, air conditioning, HVAC, is where most of the energy consumption has been observed. So moreover, this we can break down into centralized air conditioning plants like condenser water loops. Another big HVAC consumer is car park ventilation and miscellaneous bathroom fans and pumps, lighting, lifts and water pumps. So here's the electricity consumption by category of plant on a typical building that we've seen that has had inefficient HVAC systems and lighting. So the HVAC energy consumption is about 40% of the building's consumption. And we've noted that the lighting is about 31%. And that's when the lighting is not of the efficient type. Also, lifts can also have a significant energy consumption as well. So let's have a look at the type of plants that we have encountered in these high-rise towers. And they're mainly, we call this a condenser water loop. So what it does, it's for indoor, it's to reject heat from indoor air conditioning units. So as opposed to having an outdoor unit installed for air conditioning, so a lot of buildings don't have that. They just have the indoor unit and the heat is rejected via a reticulated water system that consists of a cooling tower and a pump in its simplest form. Sometimes there might be a boiler for operation during winter to provide heating. But in cooling mode, the cooling tower cools down the water coming back from these indoor air conditioning units. So a cooling tower, picture the cooling tower as it's like a big shower that sprinkles water down inside, and then there's a fan on top that sucks air through the sides and the water's evaporated, and that evaporation effect causes the cooling of the water, and the cool water is recirculated back to the indoor units. So I'd like to also show you a practical example of this from one of my site visits. Just bear with me, just a short video here. So this is a baby condenser water loop and cooling tower. It's only a 7-story building with 40 apartments, so that's the cooling tower, and on top you can see the cooling tower fan. So this whole device is the cooling tower. And here are the condenser water pumps. And the thing to note with this is that it operates 24/7, so irrespective of the weather or who's in the building or what year or what time of day, this thing is going flat out 24 hours a day. And not only is it going flat out, but most of these this equipment is oversized by 40%. And to reduce the output, because it's a lot, they use valves to throttle the performance and to restrict the flow. So there's flow restriction as well. So yeah, these are major energy consumers going flat out. So another big energy user is, we said, ventilation. So we got car park exhaust fans. That's another big user, and most of these car park exhaust fans don't have any controls, and the fans are quite massive, car park exhaust and supply fans, and they consume a large amount of electricity. And there's a standard 1668.2 that if there is no carbon monoxide detector, the fan should be operating 24/7 at 100%. So people do use timers on this, but it's probably not as per the standard, and it also poses risks in that having a timer, because there could be times of the day where the carbon monoxide levels rise above limits, and that can be dangerous because carbon monoxide is odorless and could be deadly as well. So how do we reduce consumption of these large electric motors operating 24/7 and that are oversized? So the first step would be to install a variable speed drive. So what the variable speed drive does is that it modulates the frequency of the incoming electricity, so it reduces it. So electricity is provided by the electricity company at a frequency of 50 hertz. The variable speed drive has the ability to modulate that frequency to 40, 30, or even 20 hertz in some cases. And as a result, that reduces the speed of the motor. Now, the relationship is not linear. So if we, for example, reduce the speed of a motor by 20%, and in many cases, this will be enough to meet the demand, then the electricity consumption goes down by 50%. So, the increase in performance and energy efficiency benefits and benefits to the environment are exponentially great, you could say. And as a simple installation, this can be as, for example, installed as part of a fix and forget installation, where you install these on condenser water pumps and you open up the restrictor valves to 100%, and then you reduce the speed to, say, 80%, and you leave it there, and that's fix or install and forget. But if we want to achieve additional savings and in cost and greenhouse gases, we can go to smart controls. So and these are the smart controllers. So the simplest form is the direct digital controller, where a bit of smart hardware sits in the switchboard, and it takes inputs from various sources like temperatures or occupancy, and it adjusts the performance of the system accordingly. So if it's a very hot day, we could have the variable speed drive running at a maximum speed of 80%, where if it's a cooler day, we could, say, run it up to 70 or 75%. Now, the next level of DDC is called the BMS, and that's one level up. And that's when we introduce additional smart electronics to display what's happening inside the building and to communicate energy consumption and performance and alarms of equipment. But okay, the next slide. So to further describe this, we've asked from Allerton, who are a supplier of BMS and DDC systems. So Anup Singh from Allerton to do a presentation, 12-minute video. And just a disclaimer here, we're not endorsing any company or any product, but Allerton were nice enough to do this presentation, to record this presentation for us. and there are other suppliers out there. So without further ado, let's watch the Allerton presentation on DDCs. It's a 12-minute video, and I'll see you in 12 minutes. What is a DDC? What is a direct digital controller?
What it actually is, we have got a microcontroller with a microprocessor with some code built into it, and it's got some inputs and outputs that it reads from and sends an output signal. For example, I've got a DDC controller, Allerton made DDC controller here. It's got a series of inputs, which is 8 inputs, can be either analog or digital. We'll come to analog and digital later. And then it's got a certain number of outputs. So what it does is, DDC code actually represents a software program that reads from the physical values out there. That can be a temperature input, a pressure, a flow rate, or any other input that comes with the project, and interprets it, does its own calculation, and based on our functional programming, it decides an output what it needs to be doing. And the end result needs to be energy efficiency, smooth flow of processes, and fault monitoring.
If we have like analog controls in a switchboard and we want to replace them, can the direct digital controller be installed in existing switchboards?
Yes, it can do it. What happens is the direct digital control, which is often called as building management system, works on 2 to 3 different voltages. For binary inputs and outputs, it deals with 24 volt AC or 24 volt DC, depends on which relay type we use. And then it also works on the analog signals, which in standard are 0 to 10 volt DC or 4 to 20 milliamp signals. So it depends on what type of signal we are using and what sort of output we would need to interpret, it can replace those boards.
Cool. So in the context of, say, a condenser water system where we have for example, we have a cooling tower with one cooling tower fan and one condenser water pump, which is the simplest system that we've seen in terms of condenser water loops. How can a DDC help save energy?
So what DDC will do is, let's look at the scenario first. As you have told me, there's a cooling tower which has got a fan, probably a variable speed drive as well. It's got a pump with a variable speed drive, and then cooling tower is feeding the water to the package units or air conditioning units or other systems across the building. So what it needs to do is, not all the systems are operating all the time. We need to be careful on that. There needs to be a certain set of calculation that needs to happen. That means the BMS will look at the fan statuses or equipment statuses, and it will calculate a demand based on the flow rates and the valve sizes. And then based on the demand, it will modulate the pump speed up or down.
So if we have a variable speed drive installed on a pump,
yeah.
So the DDC can read the 8 kilowatt hour consumption?
Yes, it can. So what it does is, it's got a set of registers.
Yeah.
We call them points or registers. Yeah. It's got a set of points that we get from the manufacturer, and when we connect via high level, we fix up our communications with it, we can read all those values out of it.
Can you use the VSD also as a power meter instead of having a power and energy meter installed?
You can use it as yes or no to start with.
Yes.
Yes, just for the monitoring purposes and for your building tuning purposes.
Yeah. Yes.
But if you need to do billing based on the power consumption, cannot use data from the VSD.
Sure.
Because there's this legislation around it.
Yes.
And it's called the meters needs to be NMI certified, which is National Measurement Institute.
Yeah.
And as long as those meters are certified, you can use those kilowatt hours and build the tenants. But the data from the VSD is not certified. Yeah. But it's fairly accurate, it's just not certified.
Yeah.
You can use it for your building tuning purposes.
Yeah, I mean, for most of the people that are listening here who are strata building managers and committee members,
right,
I think the interest would be to monitor the energy consumption almost real time, or on a daily basis or on an hourly basis.
Yes, so BMS can do all those calculations for you. So we can generate some dashboards
Yeah.
and you can see your daily consumption.
Yes.
So your consumption in, for example, a month of June in 2020 versus in 2019.
Okay.
And you can compare the energy usage present week versus the previous week, and you can even do the projection for next week.
Okay.
So, it's all sort of how we work with the consultant.
The projection for next week, can you explain that?
So what we will be doing is we'll be looking at your schedules.
Yeah.
So if you've got the same schedules going on for this week and the next week, or you've got some meeting rooms booked in for the special package units, we can gather that energy consumption over the year. So you've got, for example, a schedule booked in for the air handling unit. It's going to be running 8 hours a day for 4 days a week next week, versus it's been running 8 hours a day for 5 days only. So we can do some calculation around it and do a projection that approximately these many kilowatt hours your air handling unit will be using next week.
Sure.
And based on the demand and based on the weather condition, we can generate thermal energy demand for the cooling towers as well. Obviously, they're not accurate. It changes from day-to-day basis because the temperature is going up and down, but it's close enough for you to
So that projection for the cooling tower, can that be automated or is that manual? Like, can you put in weather data, for example, to get production, weather forecasts?
Yes, we can.
Automatically?
We will have to do some calculations around it, but for the end product will be automatic.
For the end product, it will be automatic?
Yes.
Okay.
So we will be integrating, so there's a term called integration.
Yeah.
So BMS has got some low-level controllers.
Yes.
It's got some temperature sensors going in, some fan start-stop commands going out.
Yeah.
And then this controller talks to a global controller, which is fairly big.
Yeah.
And it's got some IP ports connected here based on your device, if it's IP based or if it's just a low level. It's got some COM ports here. And this is the one which hosts all the graphics and all that stuff.
Okay.
The graphics that I've just shown you.
Yeah.
So this big guy have got some communication port that can talk to third-party devices. So what we can do is we can install a weather station in your building, and it will be looking at the temperature, outside air temperature, humidity, rainfall, and all those data. And we can also integrate with the data from Bureau of Meteorology.
Really?
Exactly.
That is so impressive.
Yes, and based on the weather forecast and based on your consumption that happens on the daily basis, we can generate some dashboards out for you. And you
So if a client decides to go for the full package, and they put in the weather station and they have the weather forecasting and the day's forecasted to be a cooler day, can you have a lower speed for your condenser water pumps, for example?
Yes, we can have that. And if the pump speed goes more than that, it'll raise the alarms. You can even do that.
Yeah, that's great. And for this market, I mean, the high-end solution might not be for everyone, but for some customers it'll be ideal. With the larger buildings, that'll be really ideal. I wanted to ask another question about, so if for energy efficiency purposes we install a DDC to control, say, the cooling tower and the condenser water pumps, later on as other add-ons, what else could we do? Like, could we have like monitoring for the chemical dosage in the monitoring, not actually controlling, monitoring of the chemicals and the temperatures in the cooling tower as per the new requirements for cooling towers in the city of Sydney, for example?
So let's look at the systems that are around the HVAC services.
Yeah.
So mainly when the BMS comes into place, we are expected to control the cooling tower, the pumps, the chillers, boilers, primary hot water pump, irrigation pumps, and this and that.
Yeah.
But there are other systems around the cooling towers, as you mentioned, chemical dosing system. Then they have some buffer tanks, for example. And what we do is all those systems have got low voltage terminals. They're just on-off terminals. I've just explained. They're the binary terminals, and BMS can interface with them and pick up those faults. So, for example, the cooling tower dosage system has got a fault. It's not working. BMS can pick up that signal, and based on how critical it is for you, we will be deciding that with the user, or that can be a building manager, the consultant, or anyone. We can email that alarm.
Sure.
Or we can send a text message that, your cooling tower isn't working properly, it's got such and such fault, it needs immediate attention.
And I want to talk to you about graphical interfacing. Like, obviously, there's a low level and a high level graphical interface. So
Yeah.
can you tell me what a facilities manager or a building manager, or show us on a slide what they will see in the graphical output of the BMS or the DDC system?
Yeah. So what happens is there are a few protocols that we work on. So the main and foremost protocol for building management system is BACnet, which stands for Building Automation Controls Network. So all the BMS controllers and devices, whether it's a global controller in our case or a low-level controller with some inputs and outputs we have already shown you, they all talk over BACnet. But when the third-party devices come in, they could be any other they could be using any other protocols. The other protocols could be a Modbus in terms of meters, chillers, boilers, variable speed drives, thermal energy meters, generator system, and your lifts could be talking BACnet as well, or Modbus. And then you've got your lighting interface. So when we interface with third-party devices, we read all those points. You've got both BACnet and Modbus built into our system, and 95% of the devices will be talking over these two protocols. Or there are other gateways that we can use to convert from our protocol to their ones, which works as a bridge between two systems. And as long as we read those points, we can show you all the graphics user interfaces as part of your project. You will be able to, for example, in lighting systems, you will be able to see the bulbs coming on and off. A pump running, you'll be seeing the pump going on and off. The chiller is sending some water out. You'll be seeing the AHU fan is moving. So all those stuff, we can raise the statuses out of it. And if it's in fault, it can flash, just to bring your attention in. So it depends from system to system. We can build all those graphics in.
All right, fantastic. I hope you all enjoyed that presentation. Just want to get a vibe of how much do you think that your building is in terms of BMS systems? Do you think that you are optimized or not optimized? If you could just put a comment in the chat, that'd be great. And also, so can be better, someone says. Yeah, I mean, definitely can be better. I think the question is how much money to spend and what the outcome is. So that can be a fine balance as well as doing good for the environment, obviously. Okay, so we have someone that's fully optimized. That's fantastic. And if you have any questions now regarding variable speed drives, some people have nothing. I mean, that's fine. I mean, we see a wide range of buildings. Some of them have nothing. Some of them are somewhat optimized. Some of them are fully optimized. And we see some that are very, they think they're optimized, but they're, some tuning still can be made and some savings can be made. So, and obviously there are buildings where everything's been done and nothing else further can be done. We've also seen that as well. All right, fantastic. There's someone who's interested in car park ventilation. Yeah, that's a big thing as well, and a major potential for energy saving car parks. We've seen that, massive fans running 24/7 in a lot of cases. Yeah, they consume a lot of energy. And from this presentation, what was surprising to me is the fact that these days it's relatively simple to attach information or weather data to run your building either at a lower level if the weather's cool. So that was quite impressive for me. Even though I've been in this industry for decades, it's good to hear that is available for the normal user now. So final slide on this topic. Which I have is, does this stuff work? Initially, I had planned for a building manager to come up here and do a talk and for them to give us their insight, but unfortunately, I've never done this before and I ran out of time. So the next best thing that I have for you to prove that whether this works is a table from buildings that have been generated, that are generating annual energy saving certificates under the New South Wales Energy Saving Scheme. So the New South Wales Energy Saving Scheme, they have various methods for generating these certificates. And one of them is an annual method for 10 years where from your electricity bill, after you've implemented energy efficiency measures, the savings from the bill, from the bill each year, you submit those and into a process, and then you generate the certificates. Now, each certificate is worth 1 tonne of carbon abated, or roughly 1,000 kilowatt hours. So we have 5 buildings here, and they've generated certificates they've generated between 100. This is their annual generation here, between 100 to 300 certificates. So 100 certificates, that represents $15,000 of savings a year in electricity costs, and about $1,250 a year in value of energy saving certificates. Now, these energy saving certificates can be generated for a period over 10 years. So the buildings with close to 200, they're saving $30,000 on their electricity bill per year and generating $2,500 a year in energy certificates. And the buildings here that have 300 certificates, they're generating $45,000 a year in energy savings, and probably around $3,700 in energy certificates per year, and that'll be obviously over 10 years. And they have implemented various measures. Some of them have just done the VSDs, some of them have done the VSDs and the direct digital controllers. So we have various clients here. And these numbers, they're not just plucked out of the air, so they're not my numbers, they're verified and they're audited by the New South Wales Energy Saving Scheme and IPART. So they're really fair income numbers that have been verified by third-party government body. So sorry, one minute, I think I've missed something. So let's see if, okay, we've got some questions here. So we had a look at the, we won't go to this slide yet, just answer a couple of questions before we go to that slide. So we answered the question about the car park ventilation. Yes, it's a very good thing to do. And, you know, we see typical paybacks of around 2 to 3 years, sometimes better. What type of comms links do you need across different buildings? Just a Cat6 internet cable. So just a normal internet cable, and that links to a service provider that the BMS company has set up. We've had situations where the plant room's too far from any internet cables, and not possible to do any penetrations through slabs. So another way is to have a SIM card and an annual subscription via a modem that has a SIM card. Can you use your NABERS ratings to generate New South Wales energy saving schemes? Yes, you can. There are various methods of generating energy saving certificates, and one of them is the NABERS method. So Ethan will describe those methods a bit later on into his presentation. Let me see if I can. There are no other questions at the moment. Let me see if I can unmute Ethan. So I've sent.
Hello.
Hello, Ethan. How are you?
Good, thanks, Vasilius. How are you?
Good, mate.
Excellent.
Let me stop sharing my screen, and then you can request to have your screen shared.
Okay.
Security. Oh, cool.
Let's do that.
Yep.
Okay, I will share my screen. How are we going? Can we see that?
Yep, I can see that. Fantastic.
Excellent. Okay. Still see it?
Yes.
Okay, great. Excellent. Hello, everyone. Let's have a have a talk about, in the first instance, how we can save some energy and some costs without spending anything. Everyone says there's no such thing as a free lunch, but sometimes there is when it comes to energy efficiency. So one of the things that I always encourage everyone to do, and it's one of the first things that I do when I have a new client and look at a building, is just have a quick look at their electricity tariff and see what they're on. I find a lot of the time that that they could be on the incorrect network tariff. So our local network here in the Sydney area is Ausgrid. So they have published tariff rates that doesn't matter which retailer you're with, you will pay the same network tariffs within your little local network area. So making sure that you're on the right network tariff can save thousands. For example, there's one that I commonly come across for buildings that are using between 100 and 160 megawatt hours. The difference between those two tariff rates is about $5,000 a year. So that's an easy win there. Shopping around for a good retail rate, that's one part that you have control over, and we'll have a little bit of a talk about that in a minute. The other thing as well is that doesn't cost anything a lot of the time is to just try and optimize what you've got already by monitoring it and just keeping an eye on it and maintaining it, and using things like timers and sensors to control loads. So within your electricity tariff, most buildings that are more than say 20 apartments in size, the common property will be on a time of use tariff, TOU. That means that the electricity price changes throughout the day and also throughout the seasons of the year or months of the year. So it's important to understand how your electricity tariff works, and that way you can actually take advantage of off-peak and shoulder billing periods and avoid peak billing periods. So normally, bigger buildings will be billed in two ways. Well, there's three sort of key large components to the tariff. There's a consumption charge, which is billed in kilowatt hours. And then there's a daily charge, which you don't have a lot of control over. So it's just basically fixed costs for metering and network access and that sort of thing. But then there's this other one called a demand charge. And that one, it will differ around different parts of the country, but in the Sydney area, it's particularly punitive. You really need to keep an eye on this. And it's billed on a 12-month rolling maximum. So essentially, your electricity meter measures your maximum demand over a 30-minute period between 2 and 8 p.m. Monday to Friday during the seasonal peak demand periods. And every time you hit a new high, it resets itself, and then it lasts for 12 months. So unless you do some work to reduce that and then ask the network to reset it, you're stuck with it for 12 months every time you hit a new high. So particularly worth keeping an eye on that. In particular as well, you want to try and avoid your contractors who are doing routine maintenance and that sort of thing. Just make sure that they don't do any unnecessary testing of high power plant. So for example, your car park exhaust fans or something like that during that peak billing period, 2 p.m. to 8 p.m. Monday to Friday. Otherwise, you're likely to max out your demand, your build peak demand, and be stuck with that for a year. So yeah, that's an important one. This is a little graphic from the Ausgrid website that just shows the billing period. So you can see that in the Sydney area, off peak is 10 p.m. to 7 a.m. every day. And shoulder is generally 7 a.m. to 2 p.m. and that's in the peak seasonal period. But that actually extends from 7 a.m. all the way to 10 p.m. On weekends. Sorry, not weekends. When you're not within the peak seasonal period. So that'll be the next slide. But the peak billing period, that's the one that you've got to be careful about, because you're not only being charged a very high kilowatt hour rate, so a consumption rate, but that's when your demand charge applies as well. So that applies in summer and winter periods. The other thing as well that you can do, this is outside I guess there's a couple of key ways to save energy consumption and demand, and that number one is to just reduce the number of hours of operation. So turn everything that's non-essential off when it's not in use using timers or sensors, or manual control, I suppose. That's a little bit clunkier. And the other way you can reduce the cost of consumption, of electricity consumption, is to reduce the wattage that you're using. So electricity consumption is a function of power, demand, and time. So, for example, let's take a round figure of say a 1 kilowatt pump or fan or something like that. If that 1 kilowatt pump or fan runs for 1 hour, then it has used 1 kilowatt hour of electricity. If it runs for 2 hours, it's used 2 kilowatt hours. So 1 kilowatt times 2 hours equals 2 kilowatt hours of electricity. So reducing the number of hours is one way to reduce that consumption charge, and then reducing the actual watts of the pump or fan will save as well. So reducing wattage, Vasily has talked about this before. Variable speed drives are a great way to do that. Slowing those pumps or centrifugal pumps or fans down by 20% will result in around about a 50% power saving. Just simply replacing old motors, electric motors, with modern ones, could save in the realms of 30 to 40%. So that as well. Similarly with lighting, replacing old fluorescent lights with new LED technology, might save you about 60%. Retrofitting of existing plant, and just simply maintaining it, making sure it's running properly and smoothly, and not falling apart is another way. So gas, we see quite a lot. Domestic hot water systems, large commercial domestic hot water systems with uninsulated pipework. So essentially those hot water systems are just acting like a cooling tower. They're pumping water around a network of pipes that is uninsulated, and it's just expelling its heat to the atmosphere. So that's a waste of gas. So making sure that your hot water pipe work is well insulated, and that goes for some of your hot water condenser water pipe as well. Pool covers, if you have a gas heated swimming pool, a pool cover is probably the easiest way to reduce heat loss from that swimming pool. Also reducing or adjusting your thermostat temperatures as well. So does your swimming pool need to run at 28 degrees Celsius? Does your spa need to run at 39 degrees Celsius? Knocking a few degrees off those can make a big saving for no cost at all. We can also preheat water that's going into hot water systems with heat exchangers or heat pumps or solar, but that's probably not a no cost opportunity. So going back to your energy bill, understanding that this is a typical energy bill that we see here for a large customer that's probably using over 100 megawatt hours of electricity a year. So this is called an unbundled bill. So if you compare this to the electricity bill that you might have at your house at home, you'll see that there's a lot more line items here, and these items are all actually included in your home electricity bill, but you just don't see them. So this one is, everything's itemized. So I'm not sure if you can see my cursor here. Can you see my mouse arrow?
Ethan, yes, we can. We can see.
Excellent.
Nice.
Right. Okay. So we've got a few components here. This is all your retail charges, and this is something that you've got control over when you negotiate your contract with your energy broker or directly with the retailer. You can have some control over these prices here, and then also to a lesser degree, different retailers will offer different rates for their environmental charges. So these are the ones that you actually can have some control over. These other ones here, the network charges. So if you see this EA302, that is the Ausgrid network charge. So you can see summer peak, summer shoulder, and off-peak period here. So there's nothing you can do about those. Those are fixed no matter what retailer you're with. If you're in the same network area, they'll always be the same, or they should always be the same. Similarly, this one here, this is your capacity or demand charge. So 32 cents per kilowatt per day. That one is again fixed by the Ausgrid network. It should be the same no matter what retailer you're with. This is the one I was talking about before that's in the Sydney area, is billed on a 12-month rolling maximum. So it's very important to try and keep this number as low as possible, because every time it hits a new high, then it resets and lasts for 12 months. So not a very big charge in this bill here, but you know, some sites that we see, this can be 250 or something, you know, kilowatts or kVA, and that is a significant charge. So just keep an eye on that and understand how that is billed and how it works, and try and avoid that that charge. Here again, another one, a supply charge. Again, this one's fixed by the Ausgrid network. These ones here, basically, they can vary slightly with retailer, but they're not significant in the scheme of things, you can see. So it's basically just the costs of running the Australian energy market operator. Metering charges. This is a good one actually to look at as well. So they're actually, and I come across this reasonably regularly. Sometimes there's some hidden charges here in this metering section, and that is one to look at. If your metering charges, so you might find some more itemization underneath this as well. You might see a value added service charge, or you know, other sort of daily charges that fall under this metering category. So just check that, because if it's more than about, I don't know, $5 or $6 a day under here, you're probably paying more than you need to. And there's a question to be asked of whoever set up the electricity account. Quite often we see, you know, $10 or $11, $12 a day for metering charges, and you'll usually find that there's some hidden charges in there that are going somewhere. So you want to know what, you know, where those charges are going, and what they're there for. So check on that one as well. So yes, when you're getting quotes from, say, lighting suppliers or other people, they'll usually add like a return on investment calculation or a payback period, a simple payback period, and they use an assumed electricity cost to work that out. So essentially, you know, simple payback period is the capital cost of the project divided by the annual savings that it's going to generate. And they usually use an average electricity cost on here. So the first thing and most important thing to do when you're comparing quotes like that is make sure that everyone's using the same average electricity cost. And the second one is to make sure that it's an accurate electricity cost. So you see in here that a lot of these items are charged on a cents per kilowatt hour rate, or a cents or dollars per day rate. So when you're working out your average electricity cost, you've got to exclude all this dollars or cents per day stuff. And similarly with the metering charge, because that will not change if you reduce your consumption of electricity. So you can't really include that in your average electricity price, because if you make a saving, it's not going to make any difference to those charges, because they're charged on a per day rate. So what you've got to do is try and capture all of these cents per kilowatt hour charges and get an average there. So essentially, you know, the simplest way we can do that is just add up all of these figures here that are cents per kilowatt hour, and then divide it by the total kilowatt hours, which is down here, and that will give you your average cost per kilowatt hour. Now that's probably potentially going to be a slight underestimate, because you're not taking into account this capacity charge. So it's worth working out what the savings of the project are going to be in terms of build peak demand, so you can figure that in as well. But probably a little bit complicated to go into here. So, but you know, your average kilowatt hour rate are these ones here that are cents per kilowatt hour. and your total dollars in this column divided by the total kilowatt hours for that period. And that will give you a pretty accurate cents per kilowatt hour or dollars per kilowatt hour rate for you to do your payback calcs. Something else that you can possibly do as well is if you do still have fluoros in your car park and fire stairs and that sort of thing, and you're at the point where, or you're not at the point yet where you can replace the entire fitting with LEDs, you might find that your car park or fire stairs is overlit. It's not super common. It's more likely that it's underlit, but we do find buildings from time to time that have essentially, far too many lights in the car park. So what you want to try and do is just make sure you maintain the standards, but don't exceed them in terms of lighting and that sort of thing. So the two standards that you need to look at are Australian Standard 1680, which is just for general lighting. So there's a big table in there that tells you what certain areas of your building have to be lit at, and you can get a lux meter, which you can see here, and measure that. So for example, in a car park, a general car park area, it's 40 lux in that area. So if you're exceeding 40 lux, you might be able to look at, if you have fluoros in the car park, potentially removing a fluoro tube from a double fitting, and that might save. But you've got to make sure that you still do maintain compliance. The other one is Australian Standard 2293, emergency lighting. It's generally best not to muck around with emergency lighting because it's there for a purpose, and you probably don't want to muck around with that unless you're in consultation with your emergency lighting service provider. Again, mechanical ventilation is another one. Australian Standard 1668.2 has a big list of things. So, for example, car park ventilation fans, the standard says that they must run 24 hours a day, 7 days a week, unless you monitor air quality. So that's why we like to install carbon monoxide sensors in the car park to control those fans so that they're only running the bare minimum necessary. Timers aren't compliant to the Australian standards because they're set at arbitrary times, and you could have an adverse air quality outside of those times and the fans won't run. So the best way to minimize energy consumption in a car park ventilation system is to install carbon monoxide sensors. Set point temperatures, again, I sort of briefly touched on this with your swimming pool, but again with your air conditioning systems as well. If you can, set the thermostat for the air conditioning system slightly higher in summer and slightly lower in winter, then the compressor is not going to run as much, and you should make a saving there. It's a fairly easy one. So it's essentially just adjusting those temperature set points to the highest in summer or lowest in winter that you can get away with without people complaining, I suppose. VSDs, again, Vasilius has talked pretty extensively about this. So for a centrifugal pump or fan, reducing the speed of that pump or fan, or the motor that powers that pump or fan, by 20% will result in a 50% power consumption. It's not a linear relationship, it's a cubic relationship. So that's what makes it really great is you get disproportionate power savings. So we've got a little example here. The difference between 44 hertz and 45 hertz on a motor, it's only a 2% reduction in speed, but it can result in a 7% reduction in energy savings. So that works out to about $3,000 a year on a 20 kilowatt motor. So just 1 hertz can make that much difference. Okay, some analytical tools to forecast your building's carbon footprint. So,
Ethan, can I just interrupt here? Just want to ask if anyone's got any questions for Ethan, they can pop them in the chat box, and we'll answer them after this section 3, on what he's just talked about. Thanks, Ethan. Please go on.
Okay, so there's this important little saying that I heard somewhere, and it really stuck with me, and it sums it up really nicely. It makes sense that you can't manage what you can't measure. So it's really important to establish a baseline for energy consumption. So, and then once you've established the baseline, then you can measure your ongoing performance against that, just to see if you're going up or down and investigate fluctuations. So the simplest way to do this is just to get your electricity bills and start putting them into a spreadsheet. So, and just keep track of that as you get the bills, or you can go back historically. But there's easier ways to do it as well. And most retailers offer online portals where you can log in and you can access all your energy data. You can download historic trends. You can get 30-minute interval data. You can get, bill summaries and that sort of thing. So ask your retailer, tomorrow, if you can get access to an online portal and get that data. It's amazing what you can find out by just having a look at that and monitoring it. So yeah, you've really got to keep an eye on it going forward as well, because things can easily get out of whack, and if you're not watching, you will never know. Okay, so there's the NABERS tool as well. Megan's going to talk about that in a minute as well, but this is a really good way for benchmarking your residential strata building. It's only been in place for, it's probably nearly 2.5 years now, I suppose. But the NABERS tool has been around for more than 20 years, and it's actually led Australia to be a world leader in energy performance of the commercial office sector, actually, because it's been mandatory to disclose a NABERS rating in those businesses for the over 1,000 square meters of office space for more than 10 years now, and as a result, Australia is a world leader in energy performance there. So it's been adapted for residential strata now, and it's a great way to measure your building on a level playing field against all the other apartment buildings in Australia. So we'll see if we can do a little screen share here and have a look at the reverse calculator. Can we see that, Vasilius?
Ethan, yes, yeah, we can see it.
Okay,
clearly.
great.
Thank you.
So this is the reverse calculator. It's just a simple Excel spreadsheet. You can download this from the NABERS website. If you just Google NABERS for apartment buildings reverse calculator, just pop that into Google there. You'll find this, and you can download it. I think we can post a link up as well to it for you. So it's just a simple spreadsheet. And what you do here is you've just put what star rating that you want to achieve for energy and water in here. And these are the key factors here. And this is a good thing to understand NABERS as well, is what the key things that sort of make a difference to your NABERS rating are. So you've got to pop your building postcode in there, and this basically sets different standards for thermal comfort and that sort of thing throughout the country. So in Sydney, it might be, it'll have a different adjustment factor for somewhere in Brisbane, for Brisbane or Melbourne, that sort of thing. So we put that in there, the total number of apartments, how many of the apartments are centrally air conditioned or condenser water serviced, and how many don't have it. So we just put all that data in there. Lift servicing, so if your apartments are all serviced by lifts, what sort of pool have you got? Have you got a temperature controlled pool, no pool, a heated pool? Do you have a gym? It adjusts for that. So these are different service levels of your building versus other people. So parking spaces, do you have mechanical ventilation for your parking, or is it just basically naturally ventilated? Those are the key factors that are adjusted for in the NABERS rating tool. So in terms of water, in Sydney and the Sydney area, most apartment buildings built before 2014 will just have a single central meter that covers the common property and also the tenancies. Anything approved after 2014 should have individual metering for the tenancies. So we can just adjust these numbers here based on that. Now, the other thing as well is we've got this thing here. You need the breakdown of your electricity, common property electricity and gas consumption. This is where things start to get a little bit fiddly, and it can be a little bit of a pain because there isn't a calculator to help you work out these figures. So I've made one here, which we can have a quick look at. So essentially, if you put your annual kilowatt hours of electricity in here, it uses this emissions factor, which is, again, for the Sydney area, to calculate your tons of CO2. And then your megajoules of gas in here, multiplied by this emissions factor, will give you your tons of CO2 from gas. And then using those, you can get your percentages. So that's your total tons, and that's the percentages you can see there. So we use that, and then we plug those back into here, and then we go up here and say, well, what do we want? We want a 6-star rating. We want a 6-star rating here, and it tells us down here what the maximum kilowatt hours of electricity we can consume, our common property of our building can consume in a year in order to achieve a 6-star rating. So if that is 1 more kilowatt hour, it'll bump you down to 5.5 stars. Similarly, if that's one more megajoule of gas, you'll get bumped down to 5.5 stars. So we can see how this changes. So 148,272 kilowatt hours a year is 6 stars. If we just go back up here and we drop this down to 5.5, we see that this will increase. So now we can use 222,408 kilowatt hours a year and still achieve a 5.5 star. So this is a nice little tool you can fiddle around with and see, set your goals, I suppose, and work out what you need to do in order to achieve the star rating that you would like to achieve. The other important thing to know about NABERS as well is that if you're not at the star rating you want to achieve, there's a simple way to top yourself up to as high as you want to go. And that's to purchase 100% renewable electricity or green power, accredited green power. So that means that the electricity that you're consuming on your common property at your site is sourced from a wind turbine, a solar power plant, approved hydro schemes, that sort of thing. So your emissions are essentially zero. There is no carbon emissions from those. So that allows you to achieve a better star rating. You can do that retrospectively as well, which is nice. At the end of the rating period, you can essentially purchase, the equivalent kilowatt hours of electricity from an approved renewable energy scheme through the Green Power Program, and you can achieve as high as 6.0 stars, which is great. So let's go back to the PowerPoint presentation. Okay, I think that might be the end of my section there.
Yeah, that's right. That's the end of your section, Ethan. And just wanted to ask people if they have questions, please pop them in the chat. Yeah, thanks for that information. It's really useful. I agree with you. That reverse calculator, it puts it into perspective. I've had a question here in the chat, and it says, Origin does not charge its CO2 emissions in your bill for any green power you purchase.
Okay, sorry, what was that? Can you run that by me one more time?
Origin does not change its CO2 emissions in your bill for any green power you purchase. Can you see that on the chat?
That's interesting. I think I'd have to dig into that one in a little bit more detail. I'd have to know, I suppose, what the what the tariff was and all that sort of thing. But you would think it should. That could be just a bug in their system that they don't update their graph if you've purchased green power or something.
Sure. All right.
On the graph, but yeah, we'd have to have a look at that one offline.
Sure. Okay. Fantastic. All right. Thanks, Ethan. And we've got this thing about contract, stories about contract, and you're back on there again to talk about the, I think it's the incentives, trends, and forecasts. Yep, that's right. So after this one, you're back on as well. So
okay,
I'll just put you on mute if that's okay.
No worries.
Cool. And I'll just share my screen. All right. So this is about, some of the experience that we've encountered with contracts as they're relating to energy efficiency upgrades. Most projects we find that they start happy and they finish happy, like 50 to 60%, but there's a good 30% of projects that really don't finish happy. So this story is about probably increasing the potential of finishing happy with your projects. And what we're subtopics here that we're going to look at is the context of the problem, or probably why it happens, and what are the basic what are the basics of doing things to get it right, and how we can communicate and clarify, and probably which types of contracts to use. Just a question: has anyone encountered any energy efficiency upgrade contract going sour? Or not really. So if you could just pop in the word sour into the chat, it'd be interesting to know if that's a common thing in contract management. Just going to get my chat up. Bear with me 1 minute. Which we can have a look at the end. Yeah, sorry, I just can't see my chat at the moment. I'll just proceed. I'll just proceed with this presentation. Sorry about that, about the technical difficulties here. All right. So why do we think that this may happen? Because building managers, they're overloaded, and this picture probably depicts what a building manager does, and this is just his Monday morning where they could deal with legal issues, access to contractors, day-to-day issues. They could have maintenance issues, emergency repairs. They provide psychological support to tenants and building owners, and look at compliance and cost saving. The building manager does a lot of things. So when an energy efficiency upgrade contract comes aboard, the temptation is to go to a contractor and ask them, please give me a quote. And that's an easy thing to do in the beginning, but in the end, that could be quite complicated, and it could lead to additional problems where the building manager could end up looking like the hungry coyote, and there could be legal problems, or not knowing how to evaluate the tender, or the costs may not be realized, or compliance may not be achieved. And if these things happen, it's hard for a building manager to offer the psychological support to building apartment owners and tenants as well. So the first thing that needs to be done when we're looking at a contract and requesting a quote is to compare apples to apples. So what do we mean by comparing apples to apples? Is that we need to establish the quantities and the quality of the request. The quantities and the qualities can be done by three ways. The first way, sorry, I just got someone in the chat here. Okay, fantastic. Turn off, okay, sure. One moment. Cool. The quantities and qualities can be determined by three ways, and one way would be to do it yourself. So, in the case for a lighting upgrade, go and count the lights, or go and count the variable speed drives for your pumps, for example, and then determine the quality. So we want 200 lights in the car park, and we want them to be LEDs, and we want them to have a sensor. So we've established the quantity and the quality. The second way would be to get a reference quote from the first contractor, and you can let them establish the quantities and the quality. Just probably something that you may need to consider, that this might be a bit of a burden on the contractor, because the first contractor might spend 4 hours counting your lights or counting up your equipment, whereas the other contractors may just require half an hour. So if you have a maintenance contract with a maintenance person, it's probably the best way to do that. And obviously the third way, if it's a complicated project, is to get a consultant aboard. But by no means we're not endorsing that you do that. We're just presenting the ways of doing that, but it might be needed. So the problem of establishing the quantities is not really that big a problem, because you're bound to get variations. That's the reality of the matter. So you might get you might request a quote for 200 lights, and then after you've chosen your contractor, he might go around and find an extra 50, so there might be 250 lights. Or you might request quotes for 5 3 kilowatt VSDs, and you might have 6 of them. So the way to deal with that, so that you're not being, to protect you from being overcharged, we found in the future, is to request from the contractors to put a price estimate of the variation, or a price estimate of what is potentially excluded in their quote. It's quite easy with lighting. They could say, like, for each additional 20 watt LED car park light with censored, the extra cost is $150 per fitting installed. Or the additional cost for 3 kilowatt VSD with IP54 rating for an internal plant room, not external, and it's not going to be exposed to the rain, for a 3 kilowatt VSD is $2,000 fully installed, for example. So this simple method we found can protect you from variations in the future. And the other thing that we found that can help you also is to get the basic legalities and your basic terms of conditions right and communicated to the quoting contractors in the beginning. And to help you with this, we've also prepared a document which also will be available to you at the end of this presentation. And we've got clauses, simple clauses, nothing too overly onerous, because if your documentation is too heavy, then that potentially leads to contractors pricing for risks, and your prices might potentially be more expensive. So this document that we prepared for you has things like licensed personnel, times of working, what to do when avoiding vibration, for example. It lets the contractor know that they're responsible for false fire alarms and they'll be paying for them, and make sure that they make good of the site after they go away and they clean up. So these simple clauses will help also get an understanding between you and the contractor, and it communicates them in a simple way from the beginning. And we have this template for you ready to go at the end of the presentation. In addition, it pays to communicate complexities in the negotiation. So for example, if a contractor has a terms and conditions document that's 5, 6, 10 pages long, we've seen contracts, terms and conditions that are even bigger. Sit down with them and get them to communicate their terms and conditions in 5 or 6 bullet points. Or originally, that can be done orally and then via email, just to confirm, so that each party has an understanding of these main points. And also document all the exclusions and the inclusions, so that can be agreed upon. And when problems do arise, these are nicely stated in writing, and there's no confusion as to what applies and what does not apply. So I have a story about a contract which I found, which is relative to this communication problem, and I found that it was really useful to sit down and employ communication techniques from the beginning. I'll give you the summary of the story. So we were involved in a consultancy project, which was an energy audit and design and identifying energy savings opportunities, but we were not involved in this project and in the project management. So the committee of a building and the building manager want to proceed with a lighting project, but their finances could not accommodate this. So the contractor offered to provide them with a performance agreement where they would pay back the install from their savings. The payback period was 3 years, and before they signed the document, the contractor and the building manager had multiple communication, and trust was built up, and many messages were conveyed verbally. And then the contractor sent a 20-page contract to the building manager and the committee, and which was signed. But then problems arose when the contractor started talking about a 5-year term instead of a 3-year term. And then all communication broke down, and then the project stopped. So so we were brought in as mediators, and we sat down with each party individually. First, we sat down with the contractor, and the contractor really wanted to do the right thing. He wanted a project in this building to help improve his reputation in the area and potentially get other work as well. So we mentioned that there was these were the needs from the building manager, and there was a discrepancy about the 5-year term, and the contractor mentioned that this was a standard performance agreement, and we mentioned, well, has that been communicated to the client? And where is it? And he said, well, it's in the 20-page document. So you can't expect the client to go through that document with such a fine comb, and some of these are smaller buildings as well. So we sat down and we said, well, really, you haven't communicated to us what the benefits are for the additional 2 years. Can you please list them? So the contractor sat down with us and he listed that we've extended the lighting into other areas that weren't included into the original quote. So 3 times the areas. So that's all done for free. That's all included. We're fixing all non-compliance issues with within the building at no cost. That is free. We've also going to do the fire certificate for emergency lighting annually, and that's probably worth $5,000 or $6,000 for the building. So we'll do that for free for every year. And some of the owners of the apartments, they wanted an upgraded lighting solution rather than a like-for-like replacement as we had originally quoted. So we're going to do that at an additional cost. So, I mean, and then we sat down and then we wrote all of these inclusions on a paper, and then we summarized all of these and put an estimated cost if the building was going to pay for them separately. And then we sat down with the building and the owners corporation, and we gave them objective information as to whether to pay out the contractor and complete the project now, or to go ahead with a performance agreement with these additional benefits for them to decide. So early days, but it looks like the performance contract will proceed, and because the client's getting so much benefit for so little cost. But I mean, it's a great project for both parties from our point of view as outsiders. And the problem here was that these key points were not these simple key points were not communicated between each other, firstly orally and then in writing. So, questions? Sorry, I can't see any new questions. If anyone has any questions, please type them in. The last question that I can see is about the Origin Energy CO2 emissions. Maybe we'll come back to these. I can't see any of those on my chat at the moment. And let's talk about the types of contracts that you can also use on your building. So the type of contract that we've seen used recently, and we were quite impressed with this, is a home builder's contract for work over 20,000. This can also be obtained by the Fair Trade New South Wales is a standard contract, so and it talks about things like deposits or the quality of construction, time of completion, extension of times, warranties, variations, payments, suspension and termination, disputes and notices. So it's quite comprehensive and simple to fill in. So that's the big thing. Oh, there's a question about contracts for installing power correction factor. Yes, I can see that now. So I mean, this, if your building is a as a residential strata building, this type of contract would apply to this, to the power factor correction. Unfortunately, we haven't gone into the technicalities about power factor into this presentation. But if you'd like to learn more about the technicalities of power factor correction, you could probably let us know, and we can prepare that for a future event. Yes, this also allows you to also link other documents, like the contract documents. We talked about adding your terms and conditions in the beginning, so you can also link that to that, and link your terms to this document, and it doesn't take a long time to fill out, and we've used it for recently in a project that has 120. That had the sum of the contract was $120,000 for a strata building. Cool. So I've completed this part of the presentation, and if anyone has any questions, please pop them into the chat. So alternatively, we can link up with unmute Ethan again. Let's see if, yeah, Zoom is a bit fiddly when you're going back and forth. Apologies. So Ethan, are you there?
I am.
Oh, cool.
Can you hear me?
Yes.
All right. Let's share my screen again.
Cool.
I think we're still sharing yours.
Oh, yes, you are. Yeah, yep.
There we go.
There we go.
Okay. How are we looking?
Fantastic. I can see that, and I can hear you really good.
Excellent. All right. Incentives, trends, and forecasts. Okay. So first and foremost, I think, and the best way to get your head around what incentives might be available in your area is to have a chat to your local council sustainability department. Hopefully they will have a good understanding of everything that applies in your local government area, your state government, and also federally. But what we can do is talk a little bit about the New South Wales incentives. So that's where we operate mostly. And also some of the national ones. So what we've got, a great program in New South Wales called the Energy Saving Scheme. And essentially, I think that's been going since about 2008. And it is a community funded program. So it's not a government funded program, it's community funded, which means if we go back to, let me see if I can pull this off without making a mess of it. If we go back to our electricity bill back here, can you see that, the electricity bill? We can see here we have, I think it might be covered up by this. We have these environmental schemes here. So anyway, within
Ethan, you can go one slide up.
One slide up.
Yeah.
Oop. There we go.
There we go.
Okay. So it's this one here that says NESC. So that's Energy Saving Scheme. That's the New South Wales Energy Saving Scheme. And you can see that this person who owns this bill had paid $13. So about 1% of their total bill into the New South Wales Energy Saving Scheme. So they're paying this in, and everyone in New South Wales has been paying this in since 2008. So when you undertake an eligible energy efficiency project, you can have some of that back, which is what Vasilius was talking about before with his buildings that have, you know, are getting sort of $15,000 a year or whatever it is due to their energy projects. So generally speaking, you know, roughly speaking, the energy saving scheme has roughly a 10-year deeming period. It's a little bit less for some projects. So essentially it works out how many kilowatt hours of electricity you're saving and what that equals in tons of carbon, and then multiplies that across 10 years. And you get a nice little, refund for your energy saving, refund of what you've been paying in for your energy saving work, which is awesome. So we'll just go back again. Okay. So that's a nice little thing. And within that energy saving scheme, there's quite a few different methods of calculation. The one that many people might be familiar with is the commercial lighting formula. And this is a really easy way to take advantage of the energy saving scheme. So when you replace all of those fluoros in your car park and fire stairs with LEDs, hopefully the lighting supplier has registered those lights with the energy saving scheme. And that means you're able to generate energy saving certificates for that work and get a nice little rebate. A lot of the lighting suppliers will actually just offer you a point of sale rebate up front, which is nice. So you don't have to worry about claiming things back, and it's all fairly guaranteed. There's other projects as well. So the variable speed drives and that sort of thing that Vasilius might help you out with. There's a number of different ways to calculate the energy savings from that as well, and then also generate certificates. There's this one called the Project Impact Assessment with Measurement and Verification. That's one. There's another one called Metered Baseline Method. In that way, you're generating what they call ESCs, so Energy Saving Certificates, ESCs. A nice little colloquialism of that is ESCs. You can generate ESCs for that once a year for 10 years going forward. With the Project Impact with Measurement and Verification, you can hopefully generate them all up front. So you can get 10 years in your pocket up front, which is nice, but there's usually some discount factors applied to that to accommodate for any uncertainty in the calculations. Similarly, commercial lighting formula, depending on what BCA class of building you have, the deeming period is between, say, 7 and 10 years on that, and that's a nice upfront one as well. And now the fourth one we've got here is something that's relatively new and kind of it's changed a little bit recently, but the NABERS metered baseline method. So it's just a subset of the other metered baseline method, and it basically looks at your difference in NABERS rating from year to year. So if you make an improvement in your NABERS rating and also the relative energy savings associated with that, then you can calculate energy saving certificates based on that differential as well, which is nice. So there's 4 good methods there of doing that in New South Wales. Victoria has a similar scheme. It used to be called the Victorian Energy Efficiency Target, VEET, but it's changed names now, and I can't think of exactly what it's called off the top of my head. So there's a federal scheme that we haven't listed here, and that's for solar, and that's worth doing as well. And it's almost seamless. You kind of almost wouldn't even know it's there. It's it's associated with the renewable energy target. So depending on how big a solar PV system you install, there's a federal government rebate associated with that as well. And that's a really easy one to claim, because most of the time the installer will just give you a discount off the cost of the system in exchange for those STCs or LGCs. Electricity price forecast. So electricity prices have been sort of fluctuating a bit over the last 10 years or so. You'll have seen that they've gone up and down But if you look at the general trend, it's all up. So if you look at they might have gone down in 1 year, but they've gone, they'll go up again the next year, probably by more. There was a lot of talk in New South Wales about gold plating of the electricity network, leading to excessive electricity charges. That was a big thing 5 or so years ago. Actually, network fees have come backwards slightly in many cases, but not by as much as they went up. So I guess the takeaway message here is that electricity prices are always increasing. So there's always, the best time to act and reduce your energy consumption to make those savings is now or yesterday. So I think if we just assume that prices are going to rise, it's a fair assumption. All right, NABERS. Megan's going to tell us about that.
Yeah, thanks for that. So Megan from the City of Sydney she's been really kind and generous. She's done a 17-minute presentation on NABERS and as it relates to strata buildings. So without further ado, we'll start this presentation.
Thank you for the opportunity. My name is Megan from City of Sydney Council. I'm part of a small team dedicated to engaging with and incentivising owners corporations to invest in upgrades that will future-proof their building and communities against the impacts of climate change. Through our Smart Green Apartments program, we've directly supported projects that are generating 17,000 tonnes of greenhouse gas emission reductions and cost savings of $2.4 million a year for our owners corporations. 12 of our apartment buildings have implemented Sydney WaterFix and are saving 250 megalitres of water and over $1 million a year in reduced water bills. Perhaps the single greatest driver to achieving these outcomes has been the introduction of NABERS for apartment buildings, and it gives me great pleasure to talk about it today. So what is NABERS? NABERS is an acronym for the National Australian Built Environment Rating System and is an initiative of the federal government. Launched in 1998 as the Australian Building Greenhouse Rating Scheme, it was designed to assist owners and tenants reduce energy use and costs by making energy consumption visible using a simple 1 to 5 star rating system. While the parameters of the initial scheme have expanded, the intent has remained, and at its most basic level, NABERS provides a framework for measuring and benchmarking building efficiency and providing a roadmap for improvement. In the 2 decades since it was launched, tools have been developed for other key sectors, including shopping centres, hotels, data centres, public hospitals, and apartment buildings. Tools to rate residential aged care and retirement living, public and private schools, warehouses, and cold stores are in the pipeline for development by 2025. Now, you may be familiar with other rating tools in the market. Generally speaking, these tools are used to rate building design and construction before they are built and are either compliance-based, as is the case for BASICS and NAFAs, or industry-led voluntary schemes like Green Star and LEED. In contrast, NABERS rates actual, not intended, operational performance. NABERS has international recognition and has been adapted for use in the UK and New Zealand and has been piloted in Hong Kong, Indonesia, and India. Before we look more closely at NABERS for apartment buildings, I thought it would be instructive to look at the impact the tool has had in the more mature commercial office sector. Now, if you ignore the outlier year 2010, the top graph shows that almost 16,000 ratings have been issued over a 10-year period, representing 78% of total office floor space nationally. The graph below depicts a year-on-year step change increase in the average star rating. This upwards trajectory is exactly what we want to see replicated across all sectors and comes about through a combination of continuous improvement and government intervention. As a case in point, In 2011, the federal government mandated that all offices with a floor space of over 1,000 metres square were required to disclose their rating at the point of sale or lease. And this is why you see NABERS energy ratings advertised on billboards and real estate listings. On the back of this, most government agencies and big business introduce procurement policies that require a minimum Energy Star rating for the acquisition or lease of property, which has in turn pushed property developers and managers to lift the standards of building design and performance. In the residential sector, buyers are increasingly looking at the operational performance and green credentials of apartment buildings to inform buying decisions. Research undertaken by the University of Technology in 2018 reported that 95% of survey respondents were in favour of a system that would provide information on building performance as a proxy indicator for ongoing operational costs. And it's easy to see why when you consider that in large apartment buildings, 60% of total energy consumption comes from shared services and common areas, and 25% of expenses are attributed to utilities, which are ultimately passed on to owners through strata levies. It stands to reason then that everyone, regardless of their persuasion, has a stake in ensuring that the resources used to power our vertical communities are used as efficiently as possible. NABERS for apartment buildings was launched by the Honourable Lord Mayor of the City of Sydney in June 2018 with an ambitious goal to rate 100 buildings within its first year. This goal was achieved, and in fact NABERS for apartment buildings has had the fastest uptake of the tool across any sector, providing further evidence of market demand for the kind of information it yields. To date, 160 buildings have received a first-year energy and water rating, including 7 second-year ratings. The average energy and water rating is sitting at around 3 stars, which, if you recall from earlier slides, is consistent with the baseline when it was introduced to the office sector. So what does a 3-star rating mean? Well, it means it's bang on average, not terrible, but not great either. And much like the narrative of my school report cards, there is room for improvement. Because it's not mandatory for residential buildings to be rated at the moment, there is no need to disclose your rating outside of the owner's corporation, which means that there is no such thing as a bad rating. Going back to the report card analogy, if you don't like the rating you are given, you can either scrunch it up and throw it in the bottom of your school bag, or you can use it for the purpose for which it was intended, as a roadmap for improvement. And of course, if it's a stellar rating, you can shout it from the rooftop and use it as a point of pride and market differentiation, as these buildings have done. To celebrate their 4-star, better than average first-year rating, the building manager from Hyde Park Towers had a plaque custom made and installed outside their building. Which is all well and good, but he'll need to dip into the petty cash to get a new one made to celebrate their new and improved 4.5-star second-year rating. Well done, Mr. Hoy, and well done, Hyde Park Towers. Let's now have a look at the methodology behind the tool. NABERS is based on a robust, reliable, and tested methodology. It can rate simple to complex strata schemes, including mixed-use schemes, single strata schemes, and complex layered arrangements. It is technology neutral, meaning that the age of a building is not a predeterminant of performance, and in fact many older buildings outperform the presumably more efficient modern ones. Any building with more than 4 apartments and a minimum of 2 levels can be rated. Ratings are undertaken by third-party accredited assessors and are subject to regular compliance audits. Ratings are valid for 1 year. While voluntary now, it's entirely likely that rating and disclosure will become mandatory for apartment buildings in the near future. For this reason alone, it's worthwhile to rate now, so at the very least you have a benchmark of how your building is performing against like buildings, or a stake in the ground, so to speak. So what does it measure? In its most simple form, NABERS measures the energy and water consumption of the common property of a strata scheme or schemes. With some exceptions, It measures the energy consumption of base building plant and equipment, such as HVAC, lifts, internal and external lighting, pumps, fans, and motors. It does not measure energy use within individual apartments. And it measures water consumption. And in most cases, this will be at whole of building level and include water that's used within individual apartments. Again, there are some exceptions to this. For example, where individual metering or sub-metering is in place to isolate individual or commercial use. Now let's have a closer look at how NABERS can be used as a decision-making tool. There are 4 main steps in the rating process. The first step is to prepare for the rating. In the first instance, talk to the Secretary or Strata Manager and ask them to table a motion to apply for a rating. The resolution is an important part of gaining engagement from owners to commit to the recommendations. There is a useful fact sheet on the NABERS website which provides an overview of the tool and its benefits to owners' corporations. During this step, you'll also need to start collating inputs for the assessor. The Strata Manager will have access to this information. Obtain a quote from an accredited assessor either through word of mouth or by using the supplier directory on the NABERS website. It's important when choosing an assessor to find someone that has experience in strata, particularly for more complex governance structures. Ask the assessor to include reverse calculations and a supplementary report or action plan in their quote. This will contextualize the rating into something that is actionable. The second step involves the assessor going on site to verify the data that's been provided. In some cases, they may identify discrepancies in billing and metering that can be rectified moving forward. In fact, we know of one strata scheme that had 24 individual electricity accounts. By simply consolidating these into one account, the owners' corporation are saving $64,000 a year in fixed administrative charges. After the assessor has lodged the rating, the administrators will then review the inputs and formulas used and issue a certified rating, one each for energy and water. The ratings are valid for 12 months and should become a part of the strata record, together with any supplementary reports or action plans. During the third and fourth steps, the owners' corporation are encouraged to monitor and maintain their rating, activate building tune-ups, and plan for staged upgrades in the Capital Works Fund plan. And that's the process in a nutshell. All in, the process of obtaining a rating should take 2 to 3 months, longer if key inputs are missing. Before we go further, I wanted to spend a minute talking about how green power can be used to enhance a NABERS rating. You'll see here on the slide certificates for Glow on the left and Maestro on the right. Both buildings have achieved a 6-star market-leading energy rating and are the first 2 in Australia to have done so. If you look at the certificate for Maestro, you'll see a green power logo. This indicates they have purchased accredited renewable energy to offset a proportion of their emissions. Their rating without green power would be 2.5 stars, and this is also shown on the certificate. I want to stress that this approach is perfectly legitimate. Sometimes there are inherent physical and design limitations to what a building can feasibly do to improve their rating. In this case, Maestro is a relatively new development in the Harold Park precinct of Sydney. Having only recently moved in, it wouldn't have been palatable for the owners to be asked to pay a special levy to raise the capital for upgrades, and the building has limited opportunity for on-site renewables. A culture of environmental concern was embedded into the culture of the community early on, and this, combined with the realisation that the operational performance of the building wasn't brilliant, meant they were willing to explore green power. The option was presented at an AGM and received unanimous support from the Owners Corporation. The additional cost to owners for purchasing green power was around $50 per apartment per year. They now have a plan for staged upgrades and over time will reduce the proportion of offsets purchased with each re-rating. The Owners Corporation is living by its values and is proud to set a high standard for other buildings in the precinct. I'm delighted to say that both Glow and Maestro were finalists in the Environment Award category at the 2020 Strata Community Awards. We looked earlier at the evidence-based data showing how NABERS delivers reduced environmental impacts over time. We also looked at how the tool aligns with increasing consumer demand for information about the operational performance of buildings. Anecdotally, there is emerging evidence to suggest that the tool has a vital role in improving governance, decision-making, and social cohesion within strata communities by providing a common language and pathway to integrate building upgrades and renewables into capital works fund plans. If that's not enough to entice you to rate, the team at NABERS have modelled data that predicts for the average apartment building, a 2-star increase will save owners corporations $104,420 per annum in energy savings and $27,580 a year in water savings. These savings, combined with the unlocking of financial incentives for improved performance when re-rating, effectively mean that your owner's corporation will be earning money by rating. There is no better time than now to get started on the rating journey. So how much does it cost to get a rating? In the scheme of what you gain, it's practically nothing. There are 2 cost components to a rating. The first is the assessor fees, which are variable and will depend on the complexity of the scheme being rated. It also depends on whether the assessor is providing an action plan or follow-up support and whether it's a first or subsequent year rating. The second cost component is the lodgement fee, which is paid directly to NABERS. This is a fixed fee and normally costs $2,500 for a combined energy and water rating. NABERS recently announced that they are waiving the lodgement fee until the end of 2020-21 financial year as a COVID-19 relief measure. For those buildings in the City of Sydney, owners corporations can apply for a grant of up to $10,000 to cover the cost of a rating. The next round will open in early 2021, and there is a link in the slide for more information. Other metropolitan councils also subsidise the cost of a rating, and there's a link in this slide to a roundup of what other councils are offering. In closing, I hope you found this useful. If there's one takeaway message I'd like to leave you with, it's that having a rating is a good thing, no matter how poor it is. Getting a rating before it becomes mandatory is a powerful way to communicate that your strata community cares about the environment. And it sends a strong signal to current and prospective owners that you take your fiscal responsibility seriously by committing to identify opportunities for cost reductions and not burden owners with levy increases brought about by inefficient use of resources. And lastly, the process of obtaining a rating can galvanise communities by providing a platform for reflection, recognition, and future thinking. I'll leave you now with a snapshot of how Glow has gone from industry standard to a leading environmental performer to become Australia's first 6-star rated residential apartment building without green power. If you haven't already, I encourage you to sign up to our various social channels to stay informed of upcoming grants, events, training, and networking opportunities. Thank you.
Oh, fantastic. That was a really great presentation from Megan. Let me just unmute Megan and Ethan at the moment. So I have a question for you guys. Is anyone considering a NABERS rating for their building, or they have done a NABERS rating? So if you be so kind to respond in the chat. Oh, let's have a look here now.
Something else to add to that as well is that NABERS just in the last couple of days have announced that they're running another limited pilot program, which is called, let me just have a look. It is called the Energy Starters Pilot, where they're actually going to subsidise the cost of the assessor fees as well. So there's actually potentially a small window of opportunity where buildings that haven't had a first year rating yet can actually get a 100% free rating.
Cool.
Yeah, so I think OEH are offering to fund that assessor fee up to $3,000.
Yep.
And then also that coupled with the waiving of the lodgement fee means that for relatively simple buildings that aren't, don't have lots of shared services and multiple strata plans that are a bit complex, then yeah, you could be looking at potentially a free rating.
Fantastic. So there's someone that's done a formal assessment and is waiting for a long time. Someone's done 2 and they're about to start the 3rd, and someone's going to take it to committee, and some people have already done one and they're in the process of doing it, which is really fantastic. All right, thanks for that. Has anyone got any other NABERS questions or any other questions relating to what we've just presented so far? And while you're doing that, just like to let you know that we have a really simple and short survey for you to fill in, which I'll just put in the chat. There's also a question there about okay, Jake here, Energy Starters Program. As everyone can probably see this, Energy Starters Program is allowing free ratings for new buildings, and for those who haven't received one in the past 5 years. First come, first served, 100,000 budget in total. All right, that's fantastic. And here's a link to our survey. It's also got a question about if you want the resource pack with all the resources that we've talked about. Yeah. So there was a question about before. There's a question about power factor correction. So Ethan, you mentioned something there about power factor correction, about the kilowatt charge and the kVA charge, and how that. Do you have a comment about how that relates to power factor?
Yeah, sure. Power factor is one of those things that I think the electrical plant has been changing in buildings a lot over the last few years, and it's fairly rare to see a building with bad power factor anymore, in my experience. Probably one of the biggest things that contributed to bad power factor, I think, was lots and lots of fluorescent lights running 24 hours with magnetic ballasts. So where you have resistive loads like that, you can get a situation where voltage lags behind current, and you get a disproportionately high kVA reading relative to kilowatts. So as those lights have been replaced with LED, the power factor improves. Yep. Similarly, older electric motors and that sort of thing.
Yes.
A lot of them have capacitance built into them now, so that's not such an issue anymore. So, but yeah, a power factor correction unit is a very simple piece of kit, I think. Basically, it uses a capacitor bank to offset reactive power. Yep. And basically, for those buildings that use over 160 megawatt hours of electricity a year in the Ausgrid network area, they're built on kVA demand. Yep. So essentially, the bank of capacitors realigns that kVA and kilowatt demand, so it lowers your kVA demand charge essentially.
Yeah. In the early days of LED, I saw some LEDs with really high power factor. Have you seen that as well? Or
yeah, I think most of the LEDs that I've come across are probably have a 0.9 or higher power factor.
Yeah. All right.
So 1.0 is perfect. That's what you're aiming for, and it's simply the ratio of kilowatts to kVA. So if your kilowatts and kVA are the same, then your power factor is 1.0.
Sure.
Something else that's important to note as well is that Ausgrid have a network standard that says that at the point of connection to the site, your power factor should not be 0.9 or lower. or lower than 0.9. So they can compel you to install power factor correction if you have a power factor lower than 0.9, though I don't think they're actively pursuing that at this point in time.
Sure. There's one person in the audience saying that their power factor is 0.75. Will the power factor correction unit solve this problem?
More than likely, yeah.
Despite their LEDs, yeah.
Definitely, 0.75 is pretty low. 0.745 is very low. So,
yeah.
It's definitely worth looking into that. If you've already done LED conversion,
yep.
It'd also be interesting to try and investigate what's causing that as well. There must be something else around the place that's causing it. So,
yep.
I'd suggest that there might be wider issues there as well that might need addressing.
Sure. I've got a question for Megan now with NABERS. Currently, it's a voluntary scheme. So how does it look like it might be mandatory in the future? What's the uptake rate in your opinion?
Well, it's been a very fast uptake to date. As I said in the presentation, it's had the fastest uptake of any of the NABERS rating tools. Mm-hmm. And with those, with the incentives that are in place now, I expect that it will take off. What we're discovering is that there can be kind of like a gap, I guess, between like what intended performance is versus actual performance. So the more buildings that rate, the more we can see whether that is true or not. Yeah. If it's true, then we can start advocating to have those minimum standards increased, like so for basics or NAFIS, for example. And that will mean that we have a better building stock quality from the start and not have to do these expensive retrofits later. So I would say in all likelihood, there's a new building commissioner, as you would know, for strata now. There's a lot more attention on apartments from the government, and I would say it's almost certain that it will become mandatory within the next 5 years.
Sure. And do you think there's more focus because of the COVID crisis? More and more people are working from home and energy is increasing in apartment buildings? Do you think
quite possibly, yes. But then in some, it depends what area it is. I mean, we've seen some water use drastically decrease in some buildings, and they tend to be around where the main universities are. There's been a lot of international students that have gone home, and so in those cases, consumption has actually dropped. But it's an unusual time, so. Yeah.
Definitely. And there's a comment here from one of the people in the audience about the Energy Starters program and the budget, that it's for $100,000 and that applies to a lot of sectors.
That's right.
So
it's not a massive, well, it's just, I mean, it looks very appealing if you're interested in, submitting your interest to be one of those buildings that gets free rating. I would get onto it as soon as possible. If you break down the $100,000 across 6 or 7 sectors, it's really only a few ratings that would be available for residential apartments, and that's nationally. So remember, that's only available to buildings that haven't had a rating yet.
That's it. And it's, as Megan said, it's capped, and also I think only one assessor is allowed to apply for one building at a time. You can't do multiple. So I actually just applied for one today and got one approved. So that was.
Well done. Oh, Chloe from NABERS is here, and she's saying, sorry, this is for New South Wales buildings only. So it's obviously a New South Wales state government initiative.
Chloe and Nihar. And
thank you, Chloe.
Thank you, Nihar and Jake as well. And I really liked your comment, Megan, about doing the rating increases people's appetite to do more and to save energy. Is that what you find?
Yeah, absolutely. And just seeing the progress being made, even if it's just for some of the lower hanging fruit, I think gives owners a lot more confidence in investing in those bigger upgrades, particularly if they can actually visibly see that jump in their star rating. Definitely increases confidence.
Cool. Fantastic. So we haven't got any more questions. We're 3 minutes ahead of schedule, and we're going to be closing down in 3 minutes. Megan, Ethan, would you like to add something, or someone from the audience? Please type it in the chat.
Amazing scheduling, I'll say, on your.
Yeah, good timekeeping.
Yeah.
I feel like there's more NABERS people in the audience than anyone else at this point.
Okay, that's
I hope they approve.
Oh yeah, I really like both of your presentations. Fantastic. Thank you so much for working with me, and
absolute pleasure.
thank you to the audience for being attentive and being here, for sharing 2 hours of your time. That's really great, really fantastic. I hope that the information that we've all taken will help us start or continue in our sustainability journey, and I hope that we can implement things right away. That's my hope from today's meeting.
Well, Vasilios and Ethan, I think it's a really generous gesture that you've put this on. There's always a lack of information specifically for residential apartment buildings, and they have very different decision-making processes. It's very different to doing upgrades, building upgrades in a commercial environment.
Yeah.
So I think thank you for filling in that gap for clear, independent information.
Yeah, fantastic. You're welcome, and everyone's welcome. And it looks like there's an appetite for more. So in the near future, there'll be more to come, I believe. Thank you.